Remember that we said that the domain of every logarithm was 0 to infinity, excluding the number 0? So, to say this differently, the input to every logarithm must be bigger than 0. So in the past, when finding domain, we had two concerns. I just want to recall that in the past we said that we need or we want the contents inside a square root to be greater than or equal to 0. We also needed to avoid denominator being equal to 0. Right? You got to do that for every fraction. Now those concerns are still there. We still need to pay attention to those two things when finding domain. But now there's a third thing. Due to the fact that we literally said at the beginning the domain of logarithm is 0 to infinity, excluding 0. Now we want or we need the input to a logarithm to be greater than 0. So back here, for a radical, it was the contents inside the radical needed to be greater than or equal to 0. Now the input for a logarithm has to be greater than 0. We can't include the number 0 for the input to the logarithm. So let's see some examples. We'll find the domain, we'll start small. We'll find the domain of the function f of x equals log base 7 of x minus 4. So the input to the logarithm here is x minus 4. So that's why the language is important. It's log base 7 of x minus 4. That of is the word we say right before talking about the input to this function. Okay, the input to this log function is x minus 4. So we want x minus 4 greater than 0. Add 4 to both sides. We want x greater than 4. Okay, so that domain's not so bad to state, yeah? Parenthesis 4 comma infinity parenthesis. But let's look at a more challenging example then. All right. So let's find the domain of f of x equals the fraction where the numerator says 3 to the x plus root 4 minus x. This is all over 2x minus 6. And then after the fraction, we also have a plus log base 2 of 3x minus 7. You notice how much I'm trying to focus and emphasize on saying the word of there. Log base 2 of 3x minus 7. Okay, as far as finding domain goes, this question, this example is included because it has all of our principles here at play. So we've got to avoid the denominator, in this case 2x minus 6 equaling 0. We want the contents inside a radical, in this case the contents inside a radical is 4 minus x. We want that to be greater than or equal to 0. We also want the input to a logarithm. In this example, input to the logarithm is 3x minus 7. We want that to be bigger than 0. Not bigger than or equal to 0, but just bigger than 0. So we'll solve each of these in turn. Yeah, so 2x minus 6 equaling 0 eventually turns into avoid x equals 3. What about 4 minus x greater than or equal to 0? We want that to happen. You can add x to both sides, or you can swap how this is written. People tend to prefer liking the variable on the left side of the inequality. So instead of 4 greater than or equal to x, it's x is less than or equal to 4. And then let's see, we also want 3x minus 7 greater than 0, so you can add 7 to both sides and have 3x is greater than 7, and then you can divide both sides by 3, so we want x to be greater than 7 thirds. Look, so we want x to be bigger than 7 thirds, but we also need x to be less than or equal to 4. So between 7 thirds and 4, excluding 7 thirds, including 4, also excluding just one other number, the number 3. So 7 thirds, let's see, 6 thirds is 2, huh? So 7 thirds is a little bigger than 2. It's like 2.3 repeating. So from that 2.3-ish number, yeah, excluding the number 7 thirds itself, parenthesis 7 thirds, comma, oh yeah, we got to exclude 3. So 3, parenthesis, union, parenthesis 3, comma, just go up to 4, bracket. Now, 3 and 4 are adjacent integers, I get that, but the whole point of writing parenthesis 3 comma 4 bracket is we want to include the number pi, for example. Okay, let's do another one. We'll find the domain of g of x equals root 21 minus 3x plus log base 6 of 2x minus 8. So we want the contents inside the root to be greater than or equal to 0, so we want 21 minus 3x is greater than or equal to 0. Notice here in our want, we don't write the root itself. The root tells us where to look. Okay, if when people write the root in here, there's a misunderstanding, a fundamental misunderstanding of what it is we need to write down and why we need to write it down. Remember, we don't want to end up square rooting a negative number, so we have to take that which we are square rooting, which in this case is 21 minus 3x, and say, stipulate, require that that is greater than or equal to 0. We also want the input to a logarithm, in this case, the input to the logarithm is 2x minus 8. We want that to be greater than 0. So, okay, that first inequality eventually turns into x is less than or equal to 7. The second inequality, it's another want, eventually turns into x is greater than 4. So we've got x should be bigger than 4, x should be smaller than or equal to 7. So the domain is parenthesis 4 comma 7 bracket.